Hi, everybody. Welcome back to Bimbo Mentality, a podcast where we sit down with an expert and see if they can teach us about the neat things they do. My name is Bug. I'm joined as ever by my co-host, Emma. Emma, how are you doing today?
I'm doing really well, and I'm really excited after a little bit of a break to have a new episode and talk with my fellow bimbos.
Yeah, dear listeners at home, thank you for bearing with us for a little bit of a hiatus there. There was, interpersonal garbage. Yeah, job shit. My girlfriend was moving. It's just things happen. Over in the producer booth, it's Lilith doing producer shit. How are you, Lilith?
I'm good. I'm momentarily, and by momentarily, I mean for like an hour and change, suspending my hunt for a video rip of the 9 Inch Noise set from Coachella this year, which I'm trying to track down so I can watch
I've heard
in
it's
its
good.
entirety. I've seen clips. I need to watch it in its entirety.
For any former guests who were on this podcast who definitely have a link to that, throw it in the podcast server. One of you has it. And joining us this episode on our podcast is our guest, Liv. Liv is a computational physicist with 14 years experience researching subjects from cosmology to atmospheric physics. Currently, she works in weather and climate science, studying how to improve short and long-term forecasts. Welcome to the podcast, Liv. How are you doing today?
Hello, I am, I'm here. I'm excited to talk with you all about the cool stuff that I do. I completely understand things happening in life under current year circumstances, though.
Are you enjoying the lovely weather we're having?
Oh, it's...
because we're talking about weather.
It's too hot. It's April. It shouldn't be 100 degrees when I get in my car at the end of the day.
Well, so you're joining us today to talk about like weather and climate science and 15
computational physics generally.
Yeah, like 15 other things that you're
everything.
Are you optimistic that you're going to be able to think like a bimbo enough to teach us about one of them?
I mean, probably. I'm not especially smart, so I don't know if I quite qualify as bimbo, but I would love to if I could.
See, I feel like every guest says that, and then they drop like things that I would never even think of. So
I don't most of what I know from like fucking things up and having to then fix them, and that teaching me something later.
I think that's most of how learning works.
That's fair, yeah.
I was just gonna say I've never had a situation to mess up learning about weather. So,
well, I can tell you about a lot of messing up about weather. But before we get into that, I do have a real quick PSA. My views are wholly my own and in no way reflect those of my employer, the U.S. government, federal funding agencies, the United Nations Intergovernmental Panel on Climate Change, any university, research program, or philosophic consortium. If my research history or work history sounds familiar to you, no, it doesn't. If you recognize my voice, no, you don't. If you know me, or more importantly, my boss IRL, no, you don't. Please be cool, be nice, please and thank you.
Also,
okay,
Al
cool.
Roker, do not add us.
That's right.
Cool. So, Emma, what do you know about the subject of climate science and meteorology and stuff?
It's been a long time. I mean, I'm still very much like a weather nerd in the sense of like special interest. Definitely more on the weather meteorology side than the climate side, but like a couple decades ago, I did take a couple classes on weather and climate and learned about things like terms that are still like bouncing around in my brain. Like, I'm probably mispronouncing this, but like Milankovitch cycles or other things involving like, there's like precession and there's like how like different orbital mechanics of Earth tie to climate. And yeah, I'm rambling now, but there's a lot. I can talk a lot about it.
You should talk a lot because you know more about weather. I'm absolutely certain you've taken more weather classes than I have. My background is not in like weather. It's not in climate science. It's not in computer science. I've done like throughout all my years of school, did zero coursework in any of those. I'm a physics girly. I studied astrophysics and cosmology. That's like what my PhD is in. But
That's so cool.
Because I have this thing where I'm completely neurotypical, I don't want to do anything unless I know exactly how it works. So I, in the course of doing my PhD research, did a deep dive on my own into not just like the physics, but also what the computer processes were that we like used to model the physics, which meant also learning about like what the hardware was that was running the physics and like doing the simulations. And so when I left academia the first time, I kind of happened to have picked up a lot of that stuff, and it made it kind of, a lot of it transfers between different like scientific and other sort of like knowledge type work. And so, yeah, eventually ended up working on weather forecasting codes and then climate models. So yeah, I don't know anything about, I know like a little bit of random stuff I picked up here and there from like my coworkers and like other scientists about, Monin-Oblakov similarities or stuff like that. But no, I'm much more in the world of like general physics and how do we do it on computers and what does that actually mean?
That's so cool though. That's awesome.
Can you talk, just for the audience's sake, like walk us through a little bit about like what you actually do just as your day-to-day job right now?
Yeah, so like I said, I do computational physics. So that is doing physics on computers. And what that means is like, I don't know if you, like when you think about like physics, you think about like a lot of math and especially a lot of like calculus type shit.
I think about playing with those little like atom molecule figurines. That's kind of what physics is to me.
Okay, but that's actually chemistry.
God damn it.
So that's like a whole different area.
So like there's a part of me that wants to say like chemistry is just a very particular kind of physics where they focus specifically on a smaller group of things. But
I would like to formally apologize to my dad, a high school science teacher who is probably listening right now.
No, I'm being like snooty. But like, I don't know. I think when a lot of people think about like their high school physics classes, if they took high school physics, it's a lot of like equations and plugging numbers into equations and stuff. And then if you like go further on and you do things where you're like using calculus to find more equations to plug numbers in, and computers are really good at that. And computers can do that to solve problems that we can't do by hand. So like you think about like Albert Einstein writing in chalk on a blackboard. Like when I was an undergrad, that was like, those kinds of problems were super fun to me. And I still love like writing out a problem on a chalkboard, but like we can't actually like solve a lot of physics problems that way anymore. And we definitely can't like model the Earth's atmosphere or like the evolution of the universe that way. So instead we put them on a computer.
I was never crazy about the chalkboard personally. I preferred the whiteboard.
No.
So that's a personal preference.
There's something like nails on chalkboard awful, but like there's something like satisfying about the sound of the chalk mark on a chalkboard, like the.
Oh yeah, no, you have a point there. I have to get
you know, like it tickles my ear.
It makes it feels so good to write on a chalkboard like that. Yeah. Plus, you can do all these like fancy tricks on a chalkboard where you like sort of like bounce the chalk as you draw to make a dashed line. This is like the thing you learned in the first day of like physics PhD school.
One of my high school math teachers ate a piece of chalk. That was kind of his thing. He just, as part of the like last day of school, he just ate a whole piece of chalk.
Did he have like a tummy ache?
Is chalk digestible, or does that just come out?
Apparently it's basically just Tums.
Yeah, I was gonna say it's like calcium carbonate, right? It's just Tums, but not.
Of course,
tasty.
calcium carbonate. That's the thing I know.
Yeah,
This will, I'm sure, be covered in a future episode of Diet Coke and Lilith's House of Snacks. One that will not be very fun to record.
Oh my god,
I can't wait.
High school. So physics was always like, speaking of high school physics, like my worst grade in high school after ceramics, which I won't get into why that was my worst grade.
I don't know if that's a thing you can just drop.
That was my worst grade, but physics was my second worst grade in high school. So
Real bimbo
I know
mentality, heads no.
We're getting into deep Emma lore.
Shout out Diet Coke, by the way. Listeners, check out Diet Coke and Lilith's House of Snacks if you haven't.
as science got more math based, I got worse. So like bio, I was pretty good. Chemistry, worse. Physics, garbage. I had no idea what I was doing.
Backtracked a little. We got a little sidetracked. Computers good.
Sorry.
Yeah,
Computers good. Computers good.
Great. My grandmother was a computer, so like computers extra good for that.
What?
Look, my grandmother was a computer. Yeah. Before computers were things,
Okay.
it was like a job that a person could have to like do calculations by hand.
Oh.
Oh, like
stuff.
a person who computes. I thought you were like
Okay.
robot.
All right, cool.
Okay.
Now I get it. Yeah. Now I get it.
I'm
I
a
thought
quarter
that was
robot on my
Okay.
mom's side, actually.
Quarter robot.
So this is the second episode of Bimbo Mentality in a row then that is at least partially about cool grandmas. Shout out cool grandmas.
Yes, I was fortunate to be blessed with two extremely cool grandmas.
What's the other one do?
Oh, the other one, she left the farm, moved to New York, lived like above or like right next to Carnegie Hall, and just like snuck in all the time and like played poker with like the classical musicians and like just sort of
Incredible.
hung out. She was like a 1940s scene girl.
Did you hang out with Andrew Carnegie? Wait, he's probably way older than that, isn't he?
Yes.
Gosh.
Anyway, we got sidetracked again. Computers good.
Computers good. Love my grandmas. Although after she was a computer, she then was a computer programmer. So anyway, so we can like take these equations that like say how physics systems evolve, and we can sort of put them on a computer. And we do that by like whatever it is we're trying to model or like learn about, we kind of break it up into like discrete chunks. So like in a weather forecasting simulation, you take the Earth's atmosphere and you break it up into these little volumes. We call them cells. And each one of them has like some properties associated with it, right? Like temperature in like that, for that like box of air, the amount of water vapor in it, like whether there's a cloud, if it's raining or whatever, what the wind is like there. And then we can use the equations from physics to say like, okay, what happens, let's say 20 seconds in the future, and then do that again and again and again and again. And that's how we can say, okay, here's what the atmosphere looks like now, or here's what the weather looks like now. Here's what it's going to look like tomorrow. Here's what it's going to look like. That's keep integrating the equations forward in time, and you get a 7-day forecast or a 10-day forecast in theory.
I was gonna ask, like, I'm so interested by this. Like, I'm sure we made massive advancements in the last, few years, but I know like what I've seen in the past is like, certainly when I was taking these classes, they mentioned like current supercomputers, like it's still, there's so much data if you were to think about just like Earth's weather at any given time, that it's like really hard. I guess my question is, what about Earth's weather like trips up a model where it'll, you look out 4 days and then it's like, oh, it's gonna be sunny, and then like a cold front comes through, the jet stream dips lower, and it like, what causes
Everything?
Like, are the models getting stronger, or is Earth's atmosphere just so crazy that it's like hard to know? We'll never know.
Kind of like just a problem of like the actual like system itself is so the like physics term is chaotic, because it's so, everything that happens is like super dependent on like the like initial conditions that you start with. Like when people talk about chaos theory, like this is what they mean. Like if you have like two different like states of like the weather and they're almost the same, but like there's a little difference between them, and then you just sort of like make a 10-day forecast out of both of them, you end up with like wildly different things just because like they're so sensitive to that small changes. And like literally weather and atmospheric physics is like where we like first discovered chaos theory, was in trying to do this. And so like there's sort of like a theoretical maximum that like to get like a useful weather forecast, you probably can't do that for more than 2 weeks at a time. Like you take the atmosphere today, if you had like, you know, obviously if you had like a perfect supercomputer, then you could do it, but then you would be literally specifying the location of every atom and also like what every human was going to do in the next 2 weeks, and you could keep integrating forever. But just like, you know, given if you with like a reasonable sort of set of initial conditions, like the inherent variability is just like so much that you couldn't get like more than a useful forecast for further than 2 weeks out, at least for like, you know, is it gonna rain to like 2 weeks from now? But then there's also like problems with computers themselves that also make it hard, because a computer is like, the way that a computer works is it just breaks everything down into bits, right? Everything's a 0 or a 1 or like a series of zeros and ones. And that means that there are some things that you actually can't do. Like you can't write the number 1.9 in like binary.
Wait, so
Or,
we've
like-
had a crazy twist here. Computer's bad.
No, computers are good, but like they can't do everything. I think it's 1.9. It might be 1.7. There are a bunch of numbers that you just like, you can't, that are like super simple in decimal, but you can't write them in binary. Or if you do like 0.1 plus 0.2, you don't get 0.3. You get 0.30000000004. Just because like to represent that number in binary, you need an infinite series. It's like 0.3 is the same as trying to write 0.3 in binary is the same as trying to write like 2/3 in like normal decimal numbers. And so that also introduces problems.
It's wild. That's so hyper specific.
But this is like, so like this is kind of some of the stuff that I have to think about because of like where I am and how, again, like extremely neurotypical I am, where I need to understand all sort of like levels of how this science works. I ended up in a job somehow where, despite never taking any courses in it, I work on like taking a lot of these codes and making them as fast and as accurate as I can on like really cool supercomputers. But that means like having to think about like, floating point numbers and like floating point math. Way more
That's
than
a
most
term
people.
I've definitely heard before.
Yeah, so a floating point number is like a number that you express in binary with like a certain precision, basically. It's essentially like real numbers for computers, but you only have like a certain number of digits to go out to, basically.
There's a DJ called Floating Points. I now know what that means. That's cool. I didn't know that.
Awesome.
It all comes, everything's connected.
Yeah, that's right.
This is some Illuminati shit.
I just got like, it was somebody just showed me the video of like Engin de Poitrine, the like microtonal band out of Quebec, where they're dressed like alien guys and they have like big triangles everywhere, and they start every show like this, making triangles with their hands. And now that's like all I can think about is like Illuminati alien overlords from Quebec like playing microtonal like rock music.
That's what
Anyway.
I would do if I were part of the Illuminati. Just like start a band. You know,
think
what
that
else
would
do
be-
I have to prove at that point?
Or I would build the Denver airport. That's also
Hmm.
what you could do.
Well, they already have.
But they already
that.
did that, yeah.
That's okay.
You
True.
don't need
I'd
to
build
build
more
another
tunnels.
one.
I'd build more tunnels under different airports and really creepy murals.
Just connect every airport in the country via tunnels.
Upgrade and give every airport in the United States the Denver upgrade.
Yes, with a horse that kills its creator in front. Yep. So okay, then I think like what I'm hearing and what's really interesting to learn is like, so you're trying to like find the middle ground between like knowing the limitations of computers and knowing the limitations of like just the data we can bring in and trying to find the best fit amongst all of that, it seems like.
Yeah, that's definitely part of it. Part of it though is also like trying to figure out what's the best way to actually like represent the physics itself in the code. Like, so in astronomy, like the stuff that I used to do, when we'd run like cosmological simulations of the universe, we would like, the main thing that you have to do is like calculate gravity for like everything you're simulating, right? And we do, when I was like starting, we do smooth particle hydrodynamics, or SPH, and that was, excuse me.
Oh no,
Sorry,
no, go ahead.
No, you gave a look. What was the?
No, I was just that like those words I've never heard before in my entire life. So
Okay.
Cosmological simulations of the universe is just a dope phrase. I don't know what half those words mean, but holy shit.
Yeah. But so when we run like an SPH type simulation, we would
I'm just the producer. Don't worry about me.
okay. Like you
I
have
would
all
have
these...
to simulate that.
Right. We run. So like what we do here is like we sort of break the universe up into like individual particles of like dark matter, but each dark matter particle is maybe like the size of a galaxy, but you have to calculate like the gravitational attraction between each of them, right? And you can either go through and like just do it because it's just a force, like, you know, there's an equation for the gravitational force between two particles. You can solve that for everything in your, you know, in what you're simulating. But that means that you have like a million, if you're simulating a million particles, then you have like a trillion calculations to do every time step. So there are like different algorithms that you can use to cut down on that and bring it from like a trillion particles to maybe like, instead of like having a million, or instead of having like a trillion calculations to do for each time step, you have like on the order of 6 million calculations
It's
to do
hardly
every
any
time
at
step.
all.
Well, I mean, that's like 6 orders of magnitude that you have just like sped up your simulation by. So you've made your simulation like a million times faster.
Considerable
almost.
progress.
Yeah. So that's pretty, so part of it is like trying to find sort of just algorithmic changes that we can make to like how we represent the physics in the models to make them faster. Part of it is finding different ways to represent the physics to make them more realistic. Part of it is trying to find, like, I don't know if there's like a different or better way to actually just like do stuff at root. Like there are all these different ways to do computational physics. Like you can do Lagrangian like particle stuff, like what I was just talking about with you know, in astronomy and cosmology. You can do what we do for our atmospheric models, where we have these finite volume simulations where instead of having different particles in the simulation representing bits of air, we just have like boxes that represent different parts of the atmosphere, and we calculate how much stuff moves into and out of those boxes. There are all sorts of like different methods, and you can like work out different ways that may be more or less accurate to do all of them. Yeah, so there's all sorts of fun stuff like that.
So is it accurate to say like we can't just like attack this with like more computer speed and more power? Like or is that
no,
like,
we can do that too.
Okay. We can still do that also, but we still need to do other things also.
We can do that too, but
Am I understanding correctly too that there's just always kind of a limit to how accurate it can be, because sometimes just like the jet stream has an IBS day and just everything goes haywire?
Oh hell yeah. I mean, you get stuff like catastrophic cancellation happening where like
catastrophic cancellation. Holy shit. That's the metal fucking phrase. What does that mean?
Yeah, okay. So like if like in this happens like anytime you're doing anything on a computer, but like it comes up a lot in computational physics where like you have two numbers, right? And they're both like really close to each other, and what you care about is the difference between them. Like if you have two really, like, let's say if we're talking about like in weather forecasting, for example, if you have like two different like spots on the earth right next to each other that are both like pretty warm, and what you care about is like the difference in temperature between them, because that determines which way like the rain is going to go, essentially. If you like both of those like temperature estimates for both of those parts of the earth are like pretty accurate, but not like super accurate. But basically all of the parts that are accurate in those terms are like the same between both of those estimates. And the parts that are inaccurate are the parts that are left after you subtract them. So you end up having like a difference that's you're like actually super unsure about and is super inaccurate, even though you're pretty sure you know the temperature in both places really well. You just don't know, like you might not know which one is actually warmer than the other. So you might say the rain's going the wrong way for like this period of time. So like when usually it's like you have two big numbers that you're like pretty sure are accurate, but you care about the difference between them. And that difference, you don't know if it's correct or not. That's catastrophic cancellation.
So
That's a really dope phrase for something that feels a little bit mundane, to be honest. Catastrophic cancellation sounds like a move that Lord Frieza would use in Dragon Ball Z. But
I was going to say catastrophic cancellations, like what happened to the guy who taught us all how to do the like dashed lines with the chalk on the chalkboard.
okay.
Wait, what happened to that guy?
Don't worry about it. He doesn't teach anymore. He's not around undergraduates. It's okay. It's fine. Don't worry about it.
Oh goodness. So this is like social media catastrophic cancellation.
I should say I co-host a podcast with two dear friends about like bullshit that happens in science. So like my like podcasting experience is very much like making cutting remarks about like other scientists like that.
Oh my god, is there drama? Do you ever go to like I would love to be a fly on the wall at like a scientist conference somewhere. Like is there drama? Is there like
my eyes have gone alight.
Yes.
Do you have industry beef to tell us about?
No,
Bug loves that.
I refer you back to the PSA I started the podcast with. But
I'm
no,
not
literally
looking for names.
Literally the first time I gave a conference talk at a conference, like somebody, I was a grad student. This was the first time I'd like presented my research, and another like a postdoc came up to me and was like super pissed at me for like something innocuous. I thought that was innocuous that I had said as like preamble to like the actual results. No. So the thing about computational physics and like numerical modeling in general is everybody's super pissy. The thing with the way that I think about it is like, I told you about like how like you can't do +1 or 0.1 plus 0.2, right? You don't get the right number when you do that on a computer. There's all sorts of bullshit like that happens when you try to do like model things on a computer. And so you have to come up with ways to work around that or to fix it. And everybody has their own ways of doing it. But because there's no like set, like universally correct thing, everybody has like their thing that they think is right. And if you do something else, then whatever it is, like they don't think you're right. They think like you're trash. Like people get super invested in this. It's like, yeah, I have I could go and tell a lot of stories about that.
I feel like this is like a way sort of more like lower level version of this, but I definitely feel like throughout my entire life, people have been real salty about weather reporters, and it's a little much. Like people have been like, they always just make it up on the weather report. It's like, no, I don't think that's true. I think that they're trying their best.
They are. And I mean, like,
let's cut them some slack.
That's true. Although I did grow up on a farm, so like I get it from the other side too, where you're like, come on, I gotta know, like, am I like mowing my hay this weekend, or do I need to wait? Like, come the fuck on.
Well, that's what I was gonna say too. Next is like it's we a lot of us we think about the looking at the weather report as just like, oh well, do I need to take an umbrella today? And it's like, okay, this can all seem like a lot of effort to get an exact count of that, exact accounting of that like 14 days out. But having a sense of what the weather is going to be and having as accurate a sense of what the weather could be as possible, like you get that catastrophically wrong, like that could be crop loss, that could be like train derailments and shit. So this is actually it's a lot of very kind of intricate finding these. It sounds like you hit a lot of these roadblocks with which is minutia, with just like the minor differences in rain temperature or tiny little coding problems, but it's all to get a sense of a very big important thing that is a huge part of everybody's life.
Yeah, I mean, and that happens especially with stuff like hurricanes and tornadoes, right? Where you then you really got to nail it as best you can. And so I mean, sort of what you said, Emma, is about trying to just scale up and make everything run faster so that you can make more realistic models, or just run more simulations so you have a better statistical idea of what's going to happen. That's actually my day job right now, is working on getting these simulations running on the current latest generation fastest supercomputers in the world, because for annoying reasons, we can't just make the CPUs faster and faster and faster anymore. We have to instead do things like add more CPUs, add GPUs, maybe I don't know, quantum computing. Probably not quantum computing for everything, but but in order to do that, because GPUs are different kinds of chips that are optimized for different things than CPUs, we have to rewrite a lot of the code to make it fast on the GPU instead of on the CPU. Which again, because I'm normal, because I am not because I'm I take a very I don't know, I don't want to make the same joke 3 times in a row, but I also don't want to have a better way to say it. But because I end up wanting to understand how this shit works, means I ended up in a place where I'm okay, I need to understand what the difference is and why that means this particular type of modeling, even though it's been super successful over the past 2 decades, isn't going to work as well going forwards, and what do we do to fix that or to make it work.
I mean, it sounds like you basically have to have that level of intricate understanding and curiosity about this, right? Because it's excuse me, it sounds like from what you're saying that what you do involves at least a certain amount of knowledge of a bunch of what I would think of as different pursuits, different scientific subsects and stuff.
Yeah, I mean, there's a lot of intersection there, but also I mean, I'm not a computer scientist. I know the basics of what a GPU is and why it's not a CPU. But I'm not the person who's rewriting the compiler to make it work super fast. But I understand what they're doing so that I can then go and talk to the actual climate scientists and be okay, here are our options. As a physicist, I kind of understand what you're interested in, but also here's what the constraints are from the computers. These are kind of the 3 things we can do with that.
I'm also curious, what made you switch from the cosmological and astronomical side of things to the more earthbound endeavors?
A lot of things. There was some personal stuff involved. There was some there was some stuff about just when you are an academic going through like the academic job like cycle, right? You finish grad school, you take a postdoc, you probably take another postdoc. If you're lucky, you get a tenure track offer, but you don't really like it is luck of the draw whether you get one, and if so, where. And I kind of like didn't want to just be like dragging my wife and my family around like the world in search of a tenure job. And then two, I was on the academic job market in the fall of 2016 and kind of felt like I needed to be doing something more tangible in the world. So ended up leaving academia, leaving astronomy, still miss it, still have a lot of friends there, still like, following like the James Webb Space Telescope, all of their like gorgeous pictures and data. Keeping track of like what's going on in the cosmology world as best I can. And then just like because I had this experience, doing science on supercomputers, a friend was like, hey, we need to find somebody with that experience like working for this climate change project. Do you want to do it? And I was like, yes, that's exactly what I want to do. Just purely like serendipity.
That's awesome. I love that.
Yeah.
Which is easier, predicting tornadoes or predicting meteors?
Meteors, no question, like hands down.
I figured
that was meteors coming.
I figured that was going to be the.
I was wanting to ask, we tornado like figuring out how to predict tornado genesis has been like something that has like riddled humans forever. Like we don't know why one supercell that has like almost identical conditions to another like creates a tornado and one doesn't. Still,
I have not even the foggiest idea of how tornadoes form, so that's the level of weather knowledge I'm coming into this podcast with.
There's like my understanding is roughly there's like a big thunderstorm, and sometimes the air gets so spinny that like the cloud goes to the ground.
And thunderstorms are the ones that Zeus makes.
Fun tornado fact. Yeah, fun tornado fact is like the vast majority of tornadoes on Earth, and like 99% of all violent tornadoes, like EF4 or above, are in the United States, Great Plains and the East, because of our unique North American geography. Like they don't just happen anywhere. It's like literally the perfect conditions to create them, but only east of the Rockies in the United States and Canada, mostly.
Yeah. Is it even in Canada? Yeah.
There's some in southern Canada in the summertime. Not as many, but like, and there's randomly a region. Yeah, there's randomly a region in South America that has like, it's like a second tornado alley, but it's not as big as the US one, but like it has.
I can see that, yeah.
If you think about it, that's some like high fantasy shit, right? Like
that's where like the wind elemental boss lives. Yeah.
Yes. Oh my god, I didn't even think about that.
Like, here's this like. Especially if you think about, I mean, obviously, there were people here. There have been people here for a very long time, but if you think about it from the perspective of like colonial expansion, it's like, okay, you get to like the final frontier, right? The last part of the world that has yet to be explored, and it's like, oh, there's giant, inexplicable wind monsters here.
Yeah, I think like the Great Plains, like they are a recurring prank played on like the colonial expansion like people because you get like the tornadoes, you get like the Dust Bowl, you get all this shit that keeps happening.
It makes you wonder what kind of crazy weather events we're gonna find when we finally explore outside of the ice wall. Yes.
Oh fuck.
Oh my god.
Oh my god. I thought I didn't think you can't go past the ice wall. I thought it just stretched infinitely.
No. There's an ice wall, and then there's other planets outside of the ice wall.
So there are like other ice, like sort of melted parts of the ice that have
the flat earther lore has gotten crazy.
Yeah.
Okay. There's like whole.
Okay, wait. I didn't realize you weren't talking about Game of Thrones. I have no idea what the ice wall is. Like, I thought you were talking about the wall.
Oh, I'm excited to be able
no.
to. Yeah. Okay, so for a long time, the flat Earth conspiracy has been that, like, instead of Antarctica and the Arctic Circle, there's actually a big ice wall at the edge of the Earth. And for a while,
you draw the
lore
Earth
was
as like a disc,
and it keeps and it keeps the oceans from falling off of the Earth. So, but like the new lore, because these people are just making it up as they go.
New lore drop,
is that
yeah.
in fact, there's a big like a big hole in the ice wall down at the South Pole called the Leviathan's Gate, where and you can do that to go to like the rest of the world. That like there's a whole outer world that the government's hiding from us or some shit.
Okay, I'll admit, Leviathan's Gate's a pretty good marketing term. It's
pretty cool. It's pretty cool. It's up there with it's up there with catastrophic cancellation.
I mean, it sounds like almost identical to like the first book in the Expanse series, but yes, like it's definitely
it probably is.
Yeah.
Where do you think they got it from?
I mean, you mentioned Game of Thrones too. Like this stuff is all just like pulled from osmosis from like, well, this vaguely resembles some shit I saw on TV once, so I guess it's true now.
A quick aside, Bug, did you hear about like there was like a big fracture in the flat Earth community? I think it was like last year or a couple years ago, because there was an expedition down to Antarctica, and basically like everybody who went was like, oh no, all this shit is fake. And so everybody else was like, oh, they
get excommunicated?
They got turned by the government. Yeah.
They do that every like 2 years.
It's crazy.
Like, wasn't like Logan Paul or some shit? Wasn't he part of one of those?
There was like wasn't there one guy who like went up in like a rocket, not like all the way to space, but like high enough that he could see, oh shit, the Earth is curved. Oh fuck. Yeah. And then everybody was like, they got to him.
I was
the Anunnaki, they got to him.
Oh, I was gonna say, it's not like I don't think we'll get there in our lifetime, but like if we ever got to a point where like low Earth orbit trips were just like commonplace, I feel like this would ruin the flat Earth community eventually.
But the thing is though that it wouldn't, because it's not like any of this information is hard to find. They could literally just like Google and go and watch the Twitch stream from 1.5 years ago of the last idiot who went to the South Pole to try to prove that the ice wall is there.
True.
You can use the fisheye lens, bro. You totally used the fisheye lens to make it look curved, bro.
I guess I feel bad for someone who like looked at the pictures last week from like the Artemis crew of like Earthrise coming around the moon and looking at that and being like fake and gay. Like, you know, fake and gay.
That's a soy moon, I swear to God.
We just gotta stop letting like as a culture, I think we just need to stop caring what like 20-year-olds think.
Like, they're not 20-year-olds though. Like they're like the 40 and 50-year-old like Bible thumpers, aren't they?
Well, there's also like the popular flat earthers are just like stupid 20-year-olds with Twitch streams.
I don't know. I'm not like about the popular flat earthers. I'm like more into the obscure ones. You probably haven't heard of them.
No, I got that.
The hipster.
Yeah, there are definitely the like old cranks too, but I feel like nobody listens to them. Anyway.
Okay, I changed my mind. I changed my mind from wanting to be a fly on a wall at a science conference. I want to be a fly on a wall at a flat earther conference.
Oh my god,
it can be both. I think what we should do is we should schedule a science conference and a flat Earth conference in the same building at the same time and see what happens.
Yeah,
put it in like, what is it, Pittsburgh in mid-August, is it, when they have FurryCon?
Oh yeah.
There.
Oh yeah.
Oh man, that would be the triple threat of the century.
I would.
I think it's in July.
Is it?
I think it's in July because no, I mean, it may not be, but I watched the.
I just know it's in the baseball season because like Andrew McCutcheon always tweets like furries whenever it happens.
There's an episode of The Pit this season that has them, and it takes place on July 4th this season. So I figured like that's
okay.
When furry whatever Aethercon, or I'm not sure, but
yeah.
That's anyway. So I want to go to that sometime. Sorry. Wait. Side note. Idea. we do a traveling bimbo mentality, and we go to a flat earther conference incognito.
Oh my god! Holy shit!
Do
Wait,
like get
we want you
a
to
flat earther
explain us.
on.
Yes.
this
my
is
God.
all right. We'll add this to the list of Patreon stretch goals for whenever we do a Patreon, because I'm very intrigued.
But this did
I'm
not go
very
the direction
intrigued
that
by
I
this.
thought the conversation was gonna go. And
Sorry.
It's all good.
We will.
It never
we
goes
will
the
have-
way you think it's gonna go.
We will have left this conversation more convinced of flat Earth conspiracy
Oh,
theories
no.
than when we entered it.
Oh
Anyway.
no, that's not what I wanted.
That's why
Anyway,
you
we got
left
on a-
astronomy, because you realized the truth and you couldn't handle it, and you realized.
I do have to shout out my favorite like conspiracy theory about all of this, which is that like the moon landings were faked. NASA hired Stanley Kubrick to film them, but he was such a perfectionist, he demanded that they film on site.
Yeah.
Cute.
I love
Yeah,
that one.
That's actually great. Oh my god.
That one's fun. I love to come up with just sort of like nonsense conspiracy theories. One of the I like to push the conspiracy theory that Tupac survived and moved to Malaysia, but then got assassinated in Malaysia and was replaced by a body double who is currently in hiding in Malaysia.
Was the body double in hiding, or was the body double on like MH370? And that was why that plane went down.
I mean, we can add
I'm
layers
saying
to
you
it.
can like. Oh my god, I had stuff about like. Anyway,
Yeah,
I watched the documentary about-
I was going to talk about like
went off on
astronomers
such
and
a-
how shitty we are at acronyms, or like dark
Well-
matter and black holes. But yeah, this is fun. We can keep doing conspiracy theory.
Well, we
This
can
is-
actually get to the point where we.
Okay, I was going to say, because this is like 10.2%, so I'm good to
Oh my god. Hey, so this is around that too.
Yeah, but you don't have like a beer bottle's worth of.
That's
I don't personally know the ABV percent of this cool fresh glass of California ocean spray cran apple juice, but yeah. So anyway, we went on a wild tangent there about conspiracy theorists, and I think that there is room for a part 2 here about all that stuff you were talking about like astronomy and stuff, because that sounds super cool. Is there anything about like weather and computer data stuff that you want to teach us before we wrap up?
I think just like there's like a lot of it, and it's hard to fit it on a computer. It's hard to represent it on a computer, and it's hard to make that like go forward in time accurately, like to the point where we invented a whole new kind of physics just to describe how hard it is. That's what like, literally what chaos theory is.
Which is also a dope name.
Everything I know about chaos theory, I know from Jeff Goldblum and Jurassic Park.
I was
so-
gonna say like Jeff Goldblum, Jurassic Park, just like
water going down a woman's hand.
Yeah, the life finds a way. Yeah. So you can think about like, forecasting the weather is kind of like opening up a dinosaur theme park.
That's
Interesting.
perfect. Yeah.
All right, I'll keep
Okay.
that in mind. All right, I think it's time to move into our outro here and see how you did. Emma, what'd you learn today?
I learned so much. I learned that I really need to like attend a science conference and like talk, like just see how the dynamics go. But I think in real answer, I don't think I ever considered like the limitations of computers affecting models more than like the limit of like measuring what's going on, and that was really interesting.
I have reaffirmed my belief that we should cut the weatherman a fucking break. I learned that when rain is slightly different temperatures, that's called catastrophic cancellation, which is fucking dope. I learned a lot about the flat Earth community. I think I'm really taking away that. I've learned that back in the 1940s, grandmas were computers. That's pretty dope. And I learned just about just how much just intricate little details and tiny little differences in numerical code and these little quirks of programming and measuring data that we don't really think about go into can make this huge difference in how we actually construct and build society and just keep track of all of this shit that we actually depend on to live. Having heard what we have learned about today, Liv, do you feel like you successfully thought like a bimbo and taught us about your field
I'm
of
so
expertise?
proud. Yes. You guys did great.
We did it. You said that was a test. Did we get are we getting graded? Did we
Well, I also told you that, like, because of events of current time, I didn't end up making it. But if you want, I can make one and send it to you afterwards, and we'll see how you do.
I think I would just like a letter grade.
A+.
Aw,
for both of you.
Perfect.
Yeah, hell yeah. I don't have a segue into a that's bimbo mentality, baby, today. I will be honest, but learning
That's
is
bimbo mentality, baby.
It's an A+
Thank you,
podcast. Officially, certified A+.
Thank you. Yeah, that's bimbo mentality, baby. Getting A+ for work that you only only half listening to lessons, but thinking they were really cool. Cool. Liv, do you have anything you want to plug for us before you go? I know you mentioned you have a podcast as well.
Yeah, I'm a co-host of and I guess co-producer of the Principal Instigators podcast. You can find me on Blue Sky at Shook Egg, where I post nonsense all the time in no coherent fashion. Yeah, I think that's about it from me.
Sick. Love that. That's gonna do it for us then this week on Bimbo Mentality. Our intro outro music is 10 cents per minute by Tonsil Hockey. If you have a pitch for an episode and you want to see if you can think like a bimbo enough to teach us about your area of expertise, you can send me an email at prettybug@proton.me or reach out to us on Blue Sky or Instagram. We will be resuming our bi-weekly schedule right now. We will be back in 2 weeks with an episode that I think some of our regular listeners will be very excited for. Bye-bye, everybody.